All right, in this video, we are going to continue our work on using the number line to make sense of negative numbers. Specifically, this video, we're going to use those number lines to recognize and kind of discover the rule for how to subtract negative numbers. We have some rule that we often talk about in the United States, but where does that rule come from? This video is going to help students discover the nice quick shortcut. Meanwhile, they're going to continue using the number line so that while they're still searching for the shortcut, they're going to be able to continually get the right answer using that number line visual. So let's get started. So quick recap, finding that subtraction rule. Let's remember what is the meaning of subtraction, how we're defining subtraction. We're thinking of a subtraction problem, and we're going to help our students rewrite that as an addition problem with a missing number, so that students are recognizing that we have a first change plus an unknown second change, which gives us the result. All right, so that's our starting point, and now we're going to use that and use the resulting visual representation to see if we can begin the process of finding the rule. So we're going to draw this on a number line. So let's do it. So there is, bam, our number line. And when we draw that, we know that 0 can go anywhere. So I'll just kind of put it right there. And then it says our first change is a 5, positive 5 to the right. We don't know what the second change is, but we definitely end at -7. So let's do that. So our first change is a 5. We don't know what our second change is, but it ends up at -7. So there's our result right there. So what does that second change have to be? Well, that second change has to be a change to the left. So we know that the answer is going to be negative. All right. And so both of those boxes, we can insert that negative sign. And so now we're going to say, well, what is this change to the left? If we've started at the 5 and we go all the way down to the -7, what did we do? So we're going to decompose that line into two portions. Here's a portion right here. From here to here is a -5. And then we've got another portion right here, which is -7. So thinking about putting these two together as an addition sentence, we could say, well, this is -7 plus -5, can't we? So all of a sudden, the change is -7, or that number line, when we decompose the second change, that second change becomes -7 right here plus a -5. And we know that -7 plus -5 is equal to -12. So that tells us that the answer is -12. Oh, look at that. We are starting, parents and teachers, you might start to recognize, we're starting to discover the rule. Let's do that again on another example. So let's go and we'll go to that next slide. And let's do -13 minus 8 equals what? All right. So remember, we're going to write it as an addition problem with a missing addend. So that becomes 8 plus what gives us -13. So let's draw that on our number line. So there's our line. And then, so it doesn't matter where our 0 is, I'll put it right there. So our first change is a +8 right there. And we don't know what our second change is, but we definitely know we end up at negative 13. So we don't know what our second change is, but we end up at a negative 13. So what we're going to do is we're going to decompose this second change. It's 8 to the left and 13 to the left. So let's do that nice and quickly. So we know that that second change can be decomposed to 8 to the left and another 13 to the left. And all of a sudden, that second change can be thought of as negative 13 plus negative 8, which is equal to negative 21. So we know the answer to the subtraction problem, having a hard time writing here, is negative 21. So we know that the missing add end is negative 21. Now we're starting to recognize the rule. Starting to recognize it. All right. And let's do another one where we're going to start with, because you'll notice these first two examples. Let's see. This first example here was negative 7 minus 5. So we had a negative minus a positive, and that gave us the resulting beautiful addition problem. And then we had another one where it was a negative number subtracted by a positive number, resulting in a beautiful addition problem right there. So let's now do a positive minus a negative. Let's see what happens there. So let's get to that next slide. All right, and let's do a positive minus a negative. Okay, let's do 9 minus negative 6. All right, equals what? So remember, we're going to write it first as an addition problem with a missing add end. So it's negative 6 plus what gives us positive 9. We're going to draw our number line here. And it doesn't matter where we put our 0, so I'll just kind of put it somewhere. Our first change is a negative 6. So I will go to the left 6. So our first change is a negative 6. We don't know what our second change is, but we definitely know we end up at 9. So what is that second change? Well, that second change, again, can be decomposed into two pieces. We could go from here to back to the 0, so that's a change of 6. And then we could go from 0 to 9, and that's a change of 9. So we really have 9 plus 6, don't we? So really, oopsies, a quick way to figure out what that entire second change is to just do this 9 plus this 6. And look at that, it's right there, 9 plus 6. And of course, we get the answer of 15, which means our subtraction problem is a 15. And our addition problem with a missing add end is 15. So parents and teachers, you should start to really see that classic rule that is happening and is starting to show up. Let's do one last addition. Let's see. A positive number minus a negative number. And I'm being very strategic about the problems I'm using. So let's do another example. So let's do a positive minus a negative. Okay, a positive. Let's do 23 minus, and then minus a negative. Okay, well, let's do minus 14. All right, equals what? So we're going to begin by writing that as an addition problem with a missing add-in. So negative 14 plus what gives me 23. And now we're going to model it on our number line. Here we go. Bam. There's our number line. And to model that, we're going to say, well, 0 is somewhere. Our first change was 14 to the left. 14 to the left. We don't know what our second change is, but we end up at 23. So our second change, we don't know what it is, but we end up at 23. So now we can decompose that line into two portions, can't we? We can start with the 14 to the right to get us back to the 0. Kind of dot, 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 dot. Gets us back to the 0. And that's 14. And then we can do another change, another portion to the right, and that's a 23. So all of a sudden, this second change in its entirety can really be 23 plus 14, can't it? So that becomes 23 plus 14, and that equals 37. So our answer is positive, and if I really want to be redundant, I'll put the little positive sign there, is positive 37. Okay, and again, there is our relationship. All right, so now that we've collected some data, now we're gonna look at the actual data and see if we could see some sort of pattern. Ignore the fact that some of these are outlined in yellow and others are outlined in red and green. That's just my way of boxing the answers. But here we go. Now let's take a look at, in each case we have the original subtraction problem, and then what amounts to be an addition problem, which was how that second change became decomposed into two parts. All right. So as we look at it, we can start to see that, look at this. There's something going on. What is happening in every instance of these problems? Well, what do we notice about the first number every single time? Well, what we're noticing is that the first number always stays the same, doesn't it? Okay, so the first number stays the same. So I'll write that down. First number stays the same. All right. What else do we notice? Every single time. What else is going on here? Well, we know that the answers are always the same, aren't they? Well, that's the whole point, right? So the answer works. So the answer to the addition problem is always the same as the answer to the subtraction problem. We don't need to write that down, but that happens to be a true statement. We notice, look at this, look at the operation. The minus sign becomes a plus sign. The minus sign becomes a plus sign. The minus sign becomes a plus sign. So we notice in every single case, the minus becomes a plus. So the subtraction turns into addition every single time. And then what else do we notice? Look at that second number. It was a 5, it's now a negative 5. It was an 8, it's now a negative 8. It was a negative 6, it becomes a 6. It was a negative 14, it becomes a 14. That second number always changes. Second number changes into its opposite. Woohoo! Into its opposite. So there's the three things. And then, of course, the answer always is the same, right? The answer is always the same. So it always matches. So there's our kind of our 4 things that we were supposed to discover. The first number always stays the same. The subtraction turns into addition. The second number always changes into its opposite. And the answer is always the same. There's our 4 key things that we want students to eventually start to discover. And really, parents and teachers, we want to give examples and encourage students in an inquiry mode to discover their observations of the patterns. We don't want to just give this to them in like after a day and say, oh, here, let's hurry up, memorize this rule. But we want to give them plenty of opportunity practicing, modeling subtraction on a number line so that students can begin looking for the pattern. So we've got these 4 steps. Step 1, first number stays the same. Step 2, the subtraction always turns to addition. And step 3, that second number always changes into its opposite. And that's how the answers, we get the answer. It's always the same every single time. So let's do a quick practice on that with a kind of problem that we've never seen before. Keeping in mind the rules, not the rules, just the shortcut, the observations that we noticed. First number stays the same, subtraction turns to addition, second number changes into its opposite, and the answer is always the same. We can apply that for any problem that we want. For example, if we do negative 13 minus 9, let's do 13 minus negative 9 minus negative 9. Well, we could model it as an addition problem with a missing addend. Negative 9 plus what gives us negative 13. But what we just learned is we can just, instead of modeling it on a number line, we could follow these steps up here and rewrite this problem as an addition problem. So the first number stays the same, so that negative 13 stays the same. Then we have the subtraction turns into an addition, so the negative or the minus sign turns into a plus sign. Then it says the second number changes into its opposite, so that negative 9 becomes a positive 9. And then we can do negative 13 plus 9, and we can get that answer is negative 4. So we know the answer is negative 4. But if we don't quite trust ourselves yet, we could model it on the number line down here. So let's draw it real quick on the number line. So here's our number line down here. And we can put our 0 somewhere. It doesn't matter where we put it. So let's just put it right here. There's our 0. And our first change, our first change is a negative 9. So, all right, let's do that. Our first change is a negative 9. And we don't know what our second change is. But we definitely know we end up at negative 13. All right, so we end up, oopsies, yikes, did that line thing again. We end up at negative 13. So what must our second change be if we end up at negative 13? And we can see that our second change has to be a negative 4. And there you go. So one last example to practice. Let's do 7 minus 18 equals what? All right. So our little discovery is we could, our discovery is we could write it as an addition problem. The first number stays the same. That 7 stays the same. The minus sign becomes a plus sign. The positive 18 becomes a negative 18. And then 7 plus negative 18 is negative 11. We can model that on the number line if we need to. Now, if we're not sure, let's rewrite it as, we can rewrite that subtraction problem as an addition problem with a missing addend, remember? So we have 18 plus what gives us 7. That's how we could rewrite this subtraction problem as an addition problem with a missing addend. 18 plus what gives us 7. All right, and we can model that on our number line. There's our number line. And we could say, okay, well, the first change is 18. So our first change can be 18. And what does our second change have to be to get to 7? Well, our second change, in order to get back down to 7, we have to get down to 7. So what does our second change have to be to get us down to 7? Well, it's got to be negative 11 because we're at 18. And we've got to go down 11 to get to 7. So there's our answer, which is negative 11. But we knew that. We knew that because of our addition problem that we wrote here. And here it's an addition problem. We rewrote that. So really, if you're thinking about it, we rewrote this question twice. Once as using a pattern as an addition problem. And then we also rewrote it as an addition problem with a missing addend. A couple of ways to think about this. This is really, really a cool way to think about subtracting negative numbers on a number line. It allows us to see the pattern. So in our future videos, we're going to be talking about multiplying and dividing.